The universe continues to expand, revealing more of its mysterious and awe-inspiring nature. In 1929, scientists discovered the expansion of the cosmos, a revelation that transformed our understanding of the universe's evolution. As our knowledge deepened, we realized something even more profound. Our very bodies are composed of elements forged in the hearts of ancient stars. By 1957, it became clear that the night sky, far from being a mere visual wonder, is a reflection of the staggering forces that govern the cosmos. The universe is constantly in motion, teeming with activity and mystery, much of which remains beyond our comprehension. We are left to wonder about our place in this immense system, why we exist, how planets and stars came to be, and what other possible outcomes the cosmos might have entertained. Yet human nature often leads us to overlook cosmic phenomena until they become pressing or potentially dangerous. One such example is Betelgeuse, a massive star in the constellation Orion that has recently begun to show signs of instability, trembling in a way that suggests something significant and potentially ominous may be unfolding. Betelgeuse is not just another star. It is a red supergiant, a colossal celestial body whose sheer size dwarfs that of our Sun, making our star appear minuscule by comparison. Located over 640 light-years from Earth, Betelgeuse's apparent brightness in our night sky belies its true distance. In cosmic terms, 640 light-years is a vast expanse. Traveling at the speed of light, it would take more than 6 centuries to reach it. With today's technology, realistically, it would take over 12 million years to cover that distance using conventional spacecraft, a span of time far exceeding the entirety of human history. This puts into perspective the extraordinary magnitude and power of this distant star, which has been exhibiting intense trembling and instability for some time. Although stars appear serene from Earth, they are anything but calm. Regardless of their size, stars are dynamic systems governed by complex physical processes. Scientists have long studied Betelgeuse due to its pulsating nature. It is classified as a variable red supergiant, meaning its brightness fluctuates over time. These pulsations are driven by internal mechanisms that cause the star's luminosity to vary in cycles ranging from tens to thousands of days. The tremors observed in Betelgeuse are far from ordinary and have sparked intense global interest among astronomers and astrophysicists. As one of the brightest and most massive stars visible from Earth, Betelgeuse has always fascinated scientists. However, the events that unfolded between late 2019 and early 2020 elevated this fascination to a new level. During this period, Betelgeuse underwent a dramatic and unprecedented dimming event, unlike anything recorded in recent observational history. Its brightness, normally steady and unmistakably prominent as the shoulder of the Orion constellation, suddenly began to wane, triggering a wave of speculation, analysis, and concern across the scientific community. This dimming event was not just a typical fluctuation. Stars often vary in brightness due to natural processes such as pulsations or surface activity. But what happened with Betelgeuse went far beyond expected norms. Over a matter of weeks, the star's luminosity dropped by nearly 40%, a staggering and highly unusual occurrence. For a red supergiant of Betelgeuse's size and stage in its life cycle, such a sharp decline in brightness was alarming. It suggested that something major was occurring, perhaps deep within the star's core. The phenomenon was so pronounced that amateur skywatchers could notice it with the naked eye. What was once one of the 10 brightest stars in the night sky appeared to dim so much that it temporarily lost its familiar status. This massive dimming quickly led to widespread speculation that Betelgeuse might be approaching the end of its life. Red supergiants like Betelgeuse are known to live fast and die young in astronomical terms, typically ending their lifespans in cataclysmic supernova explosions. Given its already advanced age and massive size, approximately 700 times the diameter of our Sun, the idea that Betelgeuse might soon explode became a hot topic not just in academic journals, but also in mainstream media. The prospect of witnessing a supernova with the naked eye was both thrilling and sobering. A supernova in our galactic neighborhood would be an incredibly rare and spectacular event, visible even in daylight and potentially lasting for weeks. However, as observatories across the globe and in orbit turned their attention to Betelgeuse, a different explanation began to emerge. Data collected from telescopes, including NASA's Hubble Space Telescope and other ground-based observatories, pointed to a massive ejection of stellar material from the star's surface. This cloud of gas and dust likely formed a temporary veil in front of the star, blocking some of its light and making it appear significantly dimmer from our vantage point on Earth. While this explanation ruled out an imminent supernova, it also raised new questions about Betelgeuse's internal dynamics. Why had it expelled so much material, and what did that say about its stability? In any case, the 2019 to 2020 dimming of Betelgeuse served as a cosmic wake-up call. It reminded us of the unpredictable and powerful forces at play within massive stars, and it underscored how much we still have to learn about stellar evolution and death. The tremors in Betelgeuse may not have signaled an immediate explosion, but they certainly illuminated the volatile nature of the universe's most colossal celestial bodies. The phenomenon became known as the Great Dimming. Initially, there were fears that Betelgeuse was nearing the end of its life cycle. Given that red supergiants end their lives in spectacular supernova explosions, scientists were eager and somewhat anxious to determine whether we were witnessing the early signs of such a cataclysm. Eventually, it was determined that the dimming was likely caused by a massive dust cloud ejected from the star itself, which temporarily obscured its light. This explanation provided some relief, but it also raised new questions. Why had Betelgeuse suddenly expelled such an enormous amount of material? Was this behavior a precursor to something more dramatic? In 2023, the Hubble Space Telescope and other advanced observatories continued to monitor Betelgeuse. New data revealed persistent disturbances in its outer layers, vast convective currents, and shock waves that ripple across the star's surface. These are not random. They appear to be signs of deeper instability within the star's core. Scientists believe that Betelgeuse is nearing the end of its life and could go supernova within the next 100,000 years, a blink of an eye on a cosmic scale. When it does, it will release an immense amount of energy, briefly shining as bright as the full moon, or even brighter. The explosion will be visible in daylight for weeks, possibly even months. Such a supernova would be harmless to Earth due to Betelgeuse's distance, but it would be an extraordinary astronomical event, allowing researchers to observe the life cycle of a massive star in real time. The explosion would leave behind either a neutron star or, if the core collapse is extreme enough, a black hole. Astronomers are not only watching Betelgeuse for its dramatic potential, but also for what it teaches us about stellar evolution. Every tremor, pulse, and flare offers clues about the final stages of a star's life, helping scientists refine their models and predictions for other stars, including those in our own galaxy. Betelgeuse is proving to be more than just a fascinating celestial object. It's becoming a key to unlocking the mysteries surrounding red supergiants and the colossal forces they harbor. As one of the nearest and most well-studied red supergiant stars, Betelgeuse offers astronomers a rare window into the late evolutionary stages of massive stars. Its sheer scale is awe-inspiring, around 700 times the diameter of our Sun, and yet, despite its distance of about 640 light-years, it's visible to the naked eye from Earth. But what makes Betelgeuse truly remarkable isn't just its size or brightness. It's the wildly turbulent behavior of its outer layers. Advanced observations, particularly from high-resolution telescopes and instruments that monitor infrared and ultraviolet light, have revealed that Betelgeuse's surface is anything but calm. Its outer layers are in a constant state of flux, shifting and bubbling in seemingly chaotic patterns. This dynamic activity is driven by the immense forces at play within the star, especially convection and radiation pressure. These powerful internal mechanisms transport energy from the star's core outward to its surface, but they do so with immense violence. The convection cells, regions where hot gas rises and cooler gas sinks, are far larger than anything we observe on the Sun, some spanning a significant fraction of the star's radius. These cells churn and roll with unimaginable force, creating giant, irregular patches of varying brightness on the star's surface. Radiation pressure adds another layer of instability. As Betelgeuse fuses heavier and heavier elements in its core, it generates intense energy that pushes outward. This pressure competes with the gravitational pull trying to keep the star intact, resulting in a delicate balance that is constantly on the verge of disruption. The result is a stellar surface that appears to writhe and pulsate, almost as if the star is straining to contain the furious energy within. In some cases, this internal fury manifests in violent ejections of stellar material, massive outbursts that hurl gas and dust into the surrounding space. These observations are helping scientists piece together the complex physics that govern the life and death of supergiant stars. By studying Betelgeuse's irregular surface and volatile behavior, astronomers can better understand how such stars shed mass, how they evolve over time, and what might signal their eventual collapse into a supernova. In many ways, Betelgeuse acts as a living laboratory, a natural experiment in the cosmos, unfolding in real time. Moreover, these insights are crucial for building more accurate models of stellar evolution. They help explain not just the fate of Betelgeuse, but of countless other massive stars scattered across our galaxy. Every flicker, pulse, or tremor in Betelgeuse's surface provides a clue, pointing toward the extreme, often violent, processes that govern the universe's most massive stars. It's as if the star itself is in a state of unrest, a glowing titan caught in the final acts of a dramatic cosmic performance, revealing secrets with every turbulent breath it takes. In recent months, astronomers have noted an increase in Betelgeuse's brightness again, signaling that whatever caused the great dimming has passed, but also hinting that new instabilities may be forming. Could these fluctuations be early signs of a more rapid decline? No one knows for sure. One of the most intriguing aspects of Betelgeuse is its sheer unpredictability. While models suggest a supernova is not imminent, the star continues to defy expectations. This unpredictability underscores just how much we still have to learn about the cosmos, even about stars we've observed for centuries. The story of Betelgeuse reminds us that the universe is not static. It evolves, pulsates, and occasionally surprises us in ways that challenge our understanding. And while we cannot predict precisely when the red supergiant will meet its end, we know that its death will be a cosmic spectacle unlike anything humanity has ever witnessed. Until then, we continue to watch and wonder. The night sky, after all, is not just a canvas of stars. It's a living history of the universe in motion. And somewhere within Orion's shoulder, Betelgeuse pulses like a warning light, whispering secrets of the cosmos that we've only begun to decode.